Hey there, everyone. This is Matt from AI Changes It. And I thought I would do a video today about one of the new things that's really taken off just in this week, really, and in recent history on the stock market. And that is the discussions of how we are going to get power for these data centers, these massive amounts of data centers. Everything seems to link back to AI these days. Just in general, data centers to store data, for cloud storage, for cloud applications, for artificial intelligence, sure. But we just have a huge need for this power. And for quite some time, I've actually been looking at nuclear power as being the solution to this. In fact, it's been over 2 years that I've been looking at one specific company, and it's one that just took off. And you may have found this video by searching out some information on that. This is NewScale is the name of the company. Full disclosure, I do own the stock, and I've been buying the stock actually for the past 2.5 years. To give you an example, when I started buying the stock, it was so low priced that I had to contact Fidelity when I would try to go on my phone and go in and buy SMR, which is their stock symbol. It would say, this is a penny stock and you need to get approval on your account in order to buy penny stocks to prove that you understand the risks involved in it. So I called Fidelity, and as I said, this has been almost 3 years ago that I went and did this. I called them and I discussed it with them. I got a guy on the phone. I explained to him that I already owned some of the NewScale stock. I owned it at $3 or something like that. And at the time it had gone down to $1.50. And I said I wanted to reduce my cost basis. I said, okay, I understand the risks, but I've put this much money into it at a higher price. If I buy more of it now at the lower price, my base cost will be lower so that I can have an exit strategy better. Anyways, I got it enabled on my account, was able to buy more stock at that pretty ridiculously low price. I knew back at that time, I had done my research, and I knew back at that time that nuclear was going to be a key element in so much of the technology and the grid stuff. I'm from Texas. I'm down here in Austin, Texas. And we really are the energy capital of at least North America, anyways. Maybe, well, I guess not the world. Maybe, I don't know. Anyways, we produce huge amounts of energy here. Texas is one of the top one or two producers of solar and wind. Not to mention, we also have all the refineries and we have natural gas and all of this sort of thing. So it made sense that we would continue to sit here and look at things like other power sources, to keep a very broad base and keep that cutting edge leadership that we have. So I knew that Texas would be a place that went ahead and looked at other power sources. And quite frankly, nuclear is the solution. I recently read Bono, his autobiography called Surrender. And in that, now Bono, mind you, those of you who know Bono, he's the ambassador of the world. He feeds people. He addresses injustices throughout the world. He's married to a woman who actually has made it her life's work, or one of her reasons to go in and give back to society, has been to help people and children specifically impacted by nuclear disasters such as Chernobyl and Fukushima Daiichi. That's how closely Bono is to the nuclear question. And in his autobiography, he said, as much as I have to say, he comes out and he says very bluntly, the solution to the world's energy needs in this century and going forward has to contain nuclear. It has to contain nuclear. That's a pretty glowing review by someone who, when you've won over someone like that, that it's a for real thing. It's actually going to be a real solution. And I've talked to people. I spoke to a guy I used to work with. He wanted to get into green power. And he was talking about things like, we need more solar, we need more hydrothermal, we need more, in hydroelectric and stuff like that, geothermal, excuse me. I said, well, what do you think of nuclear? He goes, oh, no, that's horrible. That stuff is horrible. No, that's the worst. He laughed at me. And I'm like, no, it's not. it's bad when something goes wrong, but everything can be bad when something goes wrong. So what you have to do is you have to find solutions that basically mitigate any problems that take place, and you have to have a almost an essentially zero tolerance for failures. Much like, say, the airline industry. We do see airline issues come up on the news, but here we are in 2024, and I can't remember the last major air disaster. They were probably the two that took place with Boeing, where their planes were at fault. It was human error back at the factory or at the design level. Anyways, and with nuclear, we have to have that same level of tolerance for failures or lack of tolerance. So that's great. We're at that point, I think, where we're getting better at that. We've learned from mistakes, and we're not Russia, who's cobbling together a system to try to supply power that's really just made out of junk, and you end up with a Chernobyl. So back to where we are today. We have data centers that are in dire need of power, and we don't want them straining the grid. So I started looking at things like the ability to build nuclear reactors that exclusively supply data centers. Again, this is over 2 years ago that I started looking into this. And I started researching companies who makes the equipment for data center, or excuse me, for nuclear power plants. I started researching all of that because I was thinking that it would have to be a 3 Mile Island size plant that would be needing to be built, and that a data center would build their own nuclear power plant. And the problem with that idea is that nuclear power plants, the ones that we traditionally think of as having the big domes where Homer Simpson works or whatever, those take like a quarter century to build at best. At best, that's a quick one. So we needed a solution that was something other than that. And it was during that research that I came to discover this technology called Small Modular Reactors, SMRs, Small Modular Reactors. And a company out of Portland, I believe, somewhere in Oregon, and they are NuScale Power. And that company, their ticker symbol is SMR, Small Modular Reactor, and they are the first licensed by the NRC, Nuclear Regulatory Commission. They're the first company to get that licensing to start building the technology that goes into making these small modular reactors. And that came down about a year and a half ago. It was after I had started buying the stock, and I found out 6-8 months into it, oh, they didn't even have the NRC regulations, but fortunately they did get the NRC regulators on their side. They got the approval for this. They were the first ones in North America. I am not sure, and maybe if you want to put in my comments here, tell me whether or not somebody else has gotten the NRC approval to build SMRs, small modular reactors. I don't know that there have been any other approved. This company is starting to sell these reactors. They're starting to, I know that the University of Texas A&M here in Austin, excuse me, oh gosh, Austinites are going to get mad at me for saying that. I almost said Texas A&M here in Austin. Texas A&M here in Texas, in College Station, I believe they bought half a dozen of these to start doing testing with and doing work with. And that's really exciting. Let me explain the idea underlying it. An SMR is a small modular reactor, and it's about the size of, it would roughly fit in one side of your 2-car garage. And it would probably need to be like 2 stories tall. So think of a 2-story tall garage, and it would fit in that amount of space. A large storage room, really. And it has a very small amount of fissionable material. I've never actually looked into the dimensions of the fissionable material that it utilizes, but I'm speculating that it's somewhere in the size of like a AAA battery. That's about how much fissionable material takes place inside of that reactor. This is not like a huge reactor that you see, Fukushima, that melted down. That have literally thousands of nuclear rods. These are very small amounts of fissionable material. It's a very small reactor, and that reactor then generates the heat, which generates the water, which heats the water, which then generates the steam, and turns a turbine, and you produce your power that way. If hopefully this doesn't happen, but if there is a accident, some sort of a failure in that system, it's such a small amount of material that it can be isolated rapidly, and can be, the way that the systems are being built, it's going to be so shielded that there is no way for that, stuff to melt down and get out of the system. And it basically will generate enough power to fuel a gigantic data center easily. Take the largest data center on the planet, and one small modular reactor could power all of that. And the waste from it, the little tiny amount of fissionable material that it has is going to last for months, if not years. Probably not years, but months, anyways. So you have something the size of a AAA battery that supplies enough power. Again, let me make sure that I'm not speaking out of turn here. I have not actually researched the amount of fissionable material that goes into these things, so don't quote me. And if you want to correct me, please do. I don't want to be giving wrong information here, but a very small amount of fissionable material is being used for that, and it lasts for months. And yeah, you have then a very toxic material that you have to get rid of, but I mean it's a negligible size. And then you put the onus upon the owners of the data center to say, okay, now we are going to regulate you, and you have to dispose of that properly. My personal opinion, we need to call Mr. Elon Musk and say, Mr. Musk, can you build a space elevator, a nice safe system for which we can get this stuff off of planet Earth, and then, put it in slow orbit back to the sun? And mind you, the sun is big. The sun is big beyond anything that we can imagine, as far as on this planet. And we're talking about a tiny amount of fissionable material. Let's just put that stuff up there, and once a year put a big ferry, a space ferry, on its way to the sun. The fissionable material, which by the way, the sun is a gigantic nuclear reaction to begin with, before that ferry ever reaches the sun, somewhere between, say, Mercury and the sun, it's going to burn up. It's going to burst into flames, and it's no longer going to be an issue. It'll be consumed by the sun as more fissionable, as a 1/trillionth of the fissionable material that the sun already has. Anyways, that's a different story altogether. The bottom line is, these things will generate huge amounts of power. And at that point, now I was watching yesterday, we had a very big day for the nuclear stocks yesterday. Amazon is getting into this business now. And so basically, we're now seeing individuals starting to talk about this. And the commentators on the network that I was watching, they were saying, I guess we're all going to have a nuclear generator under our desk. No, don't be silly. And don't be trite about it either. You can be trite if you want. That's fine. But also, these are the same people who dismissed electric cars, or their fathers, anyways, were the ones who were on TV 50 years ago. Oh, yeah, we're all going to have battery-powered cars. How many Duracells is that going to take? Whatever. And they're the same ones that were saying, that sit there and mock and belittle all sorts of things that they don't understand. No, you're not going to have a reactor under your desk. What is most likely going to happen is the data centers can be anywhere. They can be anywhere. I'm guessing companies like Microsoft, Amazon, Google, Apple, all of these companies will all be buying space out in the middle of nowhere. They'll build their data centers out in the desert. Right now, they build their data centers in city because the infrastructure is there to get the power and the fiber optic lines and all that kind of stuff out to their factories. That's where you have to build them. But if you have your own supply of power, if you're generating your own power like that, and in such a nice, small, compact way, buy your place out in the middle of the desert. Go and buy, a 10 square mile block out in the middle of the desert. Get your SMR, your small modular reactor, and then tell your architects, build a factory that will use that much power. Build your factory to the size of the power that the amount of power that you have. And they say, oh, okay, well, that's how big it needs to be. Mind you, letter number 2, small modular reactor. These are modular. So if you find you need another one, click another one in. They can be put into sequence. all added together. And as you need more power, you just add another one in as another module. And so you build your first building, you have the power running off of that. And I mean, you may build a giant data center and find we got more power than we need. You can push that back onto the grid. You can push that back onto the grid so that people living out there in, the middle of nowhere, maybe they get cheaper power. If you're closer into the cities, you can push it right back onto the state's the state's power grid. You're gonna generate excess power. That is now you have a data center that's no longer drawing off of the grid and putting the grid at risk. You actually have it reinforcing the grid. This seems like a no-brainer to me. This whole idea of utilizing these things is just a fantastic idea. Now, I see people, and by the way, over the past year or two, I have seen numerous instances where I tuned in on PBS one night and they were discussing things like power in the 21st century. And one guy was like, well, SMR sounds good, but it needs to be proven. And I'm like, okay, that's fine if you want to say it needs to be proven. But keep in mind, the United States, and now actually a dozen countries across the planet, utilize small reactors to power their fleets on the oceans. The first United States nuclear submarine was built in the 1950s, early 1950s. Here we are in 2024. That's about, 70 years we've been using these small reactors. A nuclear sub does not have a 3 Mile Island. It doesn't have Homer Simpson's power plant chugging along on it. They have small reactors that are built to the size of the ship, built to the size of, say, now an aircraft carrier or whatever these other ships are that need large amounts of power and be able to sustain that power for long periods of time. India has nuclear submarines. China, of course, has them. Russia, we know, has them. It's almost, I bet you pick the top 10 militaries on the planet, they all have nuclear vessels. Not to mention on bases and such, they also utilize small nuclear reactors. Even right here in Austin, Texas, there's a area of North Austin. It's part of the University of Texas called the Jake Pickle Research Center, the Jake Pickle Research Center. That ever since I moved here in 1970 something, it has had a nuclear reactor. We're all like, oh, there's a nuclear reactor over there, and it's right there in downtown. It's a small reactor. It's not a big thing. It's just a small one used for research. So yes, we need to prove that SMRs work, but something? I kind of think that the military has proven that a small reactor works. In other applications, like the university's research ones, have proven that it's a feasible idea in that it does work. And now, just like so many things, like our cell phones and stuff like this, and our internet and our communication systems, it started as a military thing, and now it's entering into the consumer realm, and that's really exciting. It's not some silly thing like you're going to have it up under your desk. Although I would predict maybe not in my lifetime, but I bet you as you drive down the road now, like right now, I drive down the little highway that's right here, and I know right across the street from here there is a little shack. It's not little. It's the size of like a portable building or whatever. And I went and I took a look at it, and it's actually a gas regulation gas pipeline system is right there, right in the middle of a bunch of neighborhoods and everything. And people probably 50 years ago would have said, I don't want that thing in my neighborhood. Now it's just like people don't even know it's there. The same thing is going to happen with these. Your entire city 50 years from now may have these sprinkled in throughout their cities and be generating the power, and people are just like, yeah, I don't care. Just as long as it doesn't blow up, I'm fine. And that's the same attitude we have about the gas, exchange station over here that I'm talking about. As long as it doesn't blow up, I'm fine. And so, yeah, I mean, SMR, small modular reactors, these things are for real. They really do actually have a great element of the solution for all of the energy problems faced by this world. And if you want carbon-free energy, nuclear is the answer. Bono said it. I'm saying it. I hope I've convinced you. This is where it's going. Hopefully I've helped enlighten you. All right. Thanks. Y'all have a good day. Bye-bye.